Hello my dear students. In this module we will be seeing new type of integral, and the integrals will be of the form e raised to x into brackets f of x plus f dash of x dx. Let's see the proof first. Now what we have been asked is to prove that integral of e raised to x into f of x plus f dash of x dx is equal to e raised to x into f of x plus c. Now my dear students, the proof we will start with an assumption, and that assumption is let e raised to x into f of x is some t. We will assume it to be some equal to t, variable t. Correct? Now if I differentiate both sides with respect to x, what we will get is e raised to x into f dash of x plus f of x into e raised to x is equal to d by dx of t. I am not writing it as dt by dx. There is some reason behind it. So what we get is of this form. On the left hand side, can I say that e raised to x is common? So let's take the e raised to x common. We get f of x plus f dash of x, little bit of rearrangement, is equal to d by dx of t. Correct? So my dear students, now in the next step I'll just rearrange and write d by dx of t first and e raised to x into f of x plus f dash of x, following it on the right hand side. What I have right now in front of me is of the form d by dx of g of x is equal to f of x, and this we know is the first step of the definition of integration. So as per that, can I say integral of f of x dx, this comes from where? This comes from definition of integration. Can I say that is equal to g of x plus c? So what we will get is integral of e raised to x f of x plus f dash of x dx is equal to t plus c, because that is g of x plus c. Now my dear students, the left hand side is as desired in the proof, that so that we will keep it as it is. On the right hand side we don't require a t, but we know the value of t is nothing but e raised to x into f of x. Correct? Plus c was already there. This is our equation 1, our assumption which we started the proof with, and that's the result we had been asked to prove. Now let's take some examples based on this. The question is very simple. First thing that will come to your mind is, how do I identify the sum is from this type? Predominantly in this type you will have a e raised to x out inside the integral, and following it you will have many terms. Therefore we will have to convert it into the required form. Let us see the solution. Now the solution, the first thing which I have to remember is the given integral I have to convert in the form of e raised to x into f of x plus f dash of x. That is, we need to break into two parts such that one will be taken as f of x, the second will be taken as f dash of x. Now cot x, there is nothing to simplify, so we write it as it is. From the remaining two terms, if I take a minus common and combine them together, I can think of writing a formula from my 10th standard. So in the next step, integral e raised to x as it is, cot x as it is, and minus of 1 plus cot square x. 1 plus cot square x is nothing but cosec square, so we get minus of cosec square x and dx as it is. Now my dear students, after e raised to x, inside the integral I have two terms wherein I can take f of x to be cot x, so that f dash of x is nothing but cosec square x with a minus in the beginning. So minus cosec square x. So can I say the given integral now is of the form e raised to x into f of x plus f dash of x. So the answer to it is nothing but e raised to x into f of x plus c. That is nothing but e raised to x into cot x plus c. That's our final answer. Let's take a very small question from the entrance point of view, but before that, these are the two sums which you should practice. Now the question from the entrance point of view. You have integral of e raised to x into bracket x into log x plus 1 the whole divided by x. Now my dear students, in the solution very well we can understand that we need to break into two parts such that one can be taken as f of x and the other can be taken as f dash of x. So we separate directly because denominator is a single term. So what we will get is e raised to x into bracket x log x by x plus 1 by x dx. Correct? Now in the first part, can I say x and x will get cancelled. So what we will have is e raised to x into log x plus 1 by x. Correct, my dear students? Now if I take log x as f of x and 1 by x will become f dash of x. So can I say the given integral is expressed in the form of e raised to x plus into bracket f of x plus f dash of x. So the answer will be nothing but option C, because f of x is log x. That's all we have in this module. Thank you very much.